And good news is that only 2 people missed. Only 2 people missed. That's good. People are working hard. That's good news. So this one is just a typical easy question, just to a formula question, right? Current value operation is that just constant growth. So value operation equals free cash flow, $200 times 1.06 constant growth over 0.14 minus 0.06. That is 200 times 1.06 divided by 0.08, 2650 and million, right? I told them in millions, 2650. So that's the answer, and I'm glad to say that only 2 people missed. So people are working hard, that's good. Then let's just continue our discussion. And we did NPV and IRR. IRR, I told you that is nothing more than return of the project, right? And so far so good, just kind of, in some sense, it's a kind of review. But we have to think about net present value profiles. So net present value profiles, let's say, draw net present value profiles, then what? Then you have to first, this is this one. This one is net present value table, right? So you first set up the net present value table to draw net present value profile. That's extremely important, right? So you have to just use your technology, and then let me show you that project L and project S 0 minus 100, both are same size, $100. L is 10, 60, 80, and 70. Let's go back to here. 70, 50, 20. 70, 50, 20. Like this, right? Then how to set up the table is like this. You have first use, good. First use cash flow. Second, clear work. And see if 0 is 100, right? 100 negative. And see, let's do it for L, just to save, only L to save time. C1 is 10. And C2 is 60. C3 is 80. Then go to NPV, then what? All you have to do is just check the net present value depends on WACC. So first 0, so down arrow, and compute 50, right? You got 50. Then go up and just do it 5, enter, down arrow, compute. 33.05, right? And up arrow 10, and down arrow compute, 18.78. And up arrow 15, down arrow compute, 6.67. Then down arrow, up arrow 20, enter, down arrow compute. Then minus 3.7. So I want you to do it until you see negative number. So you can stop here for LXA. But for project S, it won't be negative until 25%. So that's why we have. So in other words, in the exam, people may ask, what is the WACC, right? Then what? That means that you don't know what's going on. You have to plug in the numbers WACC yourself to set up the table. So to set up this table, to increment, this is 5% increment, right? That to decide that, you wanna just calculate IRR, right? Hit IRR and compute. Then what? 18.13. So we know that this 18.13% IRR. So if it is 18.13, if you make this increment to, let's say, 2%, then what? You have to have 10 or more rows. So that may be very bulky. So in this case, using 5% increment, then what? We have 1, 2, 3, 4, 5, just 5 rows. So I recommend you first calculate IRR and decide which, for your homework, for example, which increment do you want to make? You don't have to have too many rows, right? We have 1, 2, 3, 4, 5, 6 rows, right? But this is only 18.13, then we may have only 5 rows. But this one is more than 20%, so we need 6 rows. So like that. So you do the same to project S, and you calculate net present value one by one, depends on WACC, right? So based on this table, you draw net present value profile. It's like this. For example, so you start from 0, right? 0%, like here, 0%, L is 50. So you see 50 here. And 5%, what? 33. So it is 33. This is 33, right? So this point. And 10%, 19. So 10%. This is 19. This one. And 15%, 7. So this is 7. And 20%, 84. So this one is 84. So you connect all those points. That's how to draw net present value profile. And in this case, you have two projects. Don't draw it separately, a separate graph. You draw it together like this. So you draw net present value profile of S on the same graph, and that is yellow, right? 40 and this one, and this one, this one, this one. And there is one more that 25%, you have 2. So that is actually 25. And this one is actually 82, right? It's just, so make sure that when you set up the table, you see these negative numbers. you do it until you see the negative. The reason is, then what? You know where it crossed the x-axis, right? That is IRR, right? So we see that IRR of L is 18.1%, but IRR of S is 23.6%. So this point, right? So when you draw net present value profile, at least there are three important return. There is what? IRR of L, okay, and IRR of S, and also the crossover point or crossover rate. And we get 8.68%. And crossover point is what? Where two projects have the same net present value, right? All the other WACC net present values are different, right? And in this case, net present value of L is greater than net present value of S until WACC 5, but what? Between 5 and 6, between 5 and 6, we just change the color. Between 5 and 6, right? The present value is the same. It's 19, 20. So the present value of L is smaller than the present value of L, S. And the present value of L is greater than the present value of S. So between 5% and 10%, there is just WACC that makes the present value L and the present value S the same, right? So believe it or not, some people just try and error, just enter some discount rate to see how close this net present value L and net present value S are there. So to try to have same net present value, entering just different WACC over and over again. That's what. That's a waste of time. That's a waste of time. Besides, if this is an exam, I may ask you maybe up to 3 decimal points. Then what? Then that will be very difficult, right? Like this one is only crossover point only 2 decimal, right? 8.68%. But if I ask you up to 3 decimal points, then what? If you do this way, just plug in the WACC and see how close they are, that's a waste of time. Then,
Professor,
yeah.
Can you please explain again how you were changing IRR, like for 5, 10? I just trying to do it and I don't get the same numbers.
Oh, I did only for project L, right? Mm-hmm. So you can do project S yourself. But since you ask, let's do project S then, just.
Okay.
CF0, clear work, and CF0 is 100 negative. And C1 is what? 70, right? 70. And C2 is 50. C3 is 20, right? And then go to NPV. Just compute. Because I is 0, just compute. What's going on? Oh, it's not compute. Oh, sorry. I have to go to net present value. Down arrow, compute. 40, right? You get 40, right? Did you get 40?
Yes, I got it.
Yeah.
Got it.
Yeah, then just up arrow, I is 5, then you enter 5, enter. And down arrow, compute. 29, right? And you keep doing that, right? And up arrow, I is 10, enter. Down arrow. In other words, you have to check your NPV for each WACC.
Okay.
And you have to provide WACC yourself. So then don't ask in the exam or homework, where is the WACC? You know, some people ask that question, but that means that person doesn't know. Why? It's just you provide those ones, as I said, according to your IRR. So hit IRR and compute. 23.56%, right? So 23.56%. So you have to specify IR of L and IR of S and this crossover point. Then to calculate the crossover point, you have to just calculate delta project. So there is some important, technique is delta project, or to be just consistent, the project delta. Then it's better for you, the technique is this. Delta project is that either project L's cash flow minus project S, or project S cash flow minus project L. Both are fine, but it's better to make sure that when net present value of L or S at 0, right? 0, this is bigger, right? Right. So it's better for make it L minus S this time. If net present value of S is, let's say, 55, then what? It's better to make S minus L. But since this is bigger than 40, 50, so L minus S in this case, that's better, L minus S. L minus S. Then what? L minus 100 minus 100 is what? 0, right? 10 minus 70 is minus 60. 60 minus 50 is 10. 80 minus 20 is 60, right? So that is delta project delta. So project delta means the difference between the two projects, cash flow difference between the two projects. So in this case, this delta project is a difference between project L's cash flow and project S cash flow. Then these delta projects, net present value will be positive or negative, depends on what? Depends on WACC, right? Then what do you think? How do you calculate the crossover rate?
Let the MPVL equal to MPVS. And
yeah, that's correct. But how? How to calculate crossover rate? Any idea? Using project delta.
So use the IRR of L minus IRR of S.
Well, that's what we did. That is project delta, right? So we did. No. Yeah, they're almost there. They're almost there. Yeah. Just one more step. Almost there.
I found it taking the IRR of the cash flows from project delta.
Check. Good answer. Why? Because project deltas, let's just enter project delta's cash flow, 0, and 60 negative, and 10 enter, and 60 enter. Then what? If you use I0, then what? 10. Actually, there is what? Net present value delta is 10, right? Then we know that at 5, 33 minus 29 is 4. At 10, 19 minus 20 is minus 1. 7 minus 12 is minus 5. Minus 4 minus 5 is minus 9. Minus 13 minus 2 is minus 15, like this, right? So at other discount rate, NPV is either positive or negative. Then what? There is some discount rate that makes NPV of delta 0, right? That is actually the definition, IRR of project delta, right? So all you have to do is hit IRR and compute 8.68. 8.68. That's how to calculate crossover rate. So as you see here, at other interest like WACC 0, then what? Delta projects NPV is 10. So also, if I ask you, draw net present value profile of project L, project S, and project delta, then what? Then you have to draw maybe this color. That at 0, it is 10, right? 10, right? And at 5, it is 4. So you draw at 5, it is 4 here. And at 10, there is negative 1. So you can stop there. At 10 is negative 1. And then what? You connect those points like this, right? You connect this. And this is project delta. So that present value profile of project delta is like this.
Professor,
And you have to, yeah, question.
if you don't mind, can you show me how you got to the IRR? I got the cash flows and the NPV, but then I lost you with the IRR.
IRR, okay, no, okay. IRR is IRR of delta is, all you have to do is what? Enter cash flow 0. This is CF0, CO1, CO2, CO3, right? So enter, so cash flow 0 is 0, right? Because delta project, 0, right? So 0, and C1 is minus 60, C2 is 10, C3 is 60, right? And go to IRR, hit IRR, and compute 8.68, right? That is how to calculate IRR or project delta. Right? So as I said, your Grant Pass Finance IRR calculation is the most difficult. Polynomial, very difficult. But because of technology, believe it or not, IRR calculation for you is the most easiest. Why? For NPV, for you calculate, you have to enter I, right? But IRR, you don't have to do anything, just compute, right? So faster and easiest. So that is IRR of delta project, and that is crossover rate, 8.68%. And you have to make sure, many people make mistake in the exam or quiz, homework. This crossover rate, the crossover the x-axis, this point, that is IRR of delta, and that has to be same as this crossover point between L and S, right? So that should be right below that point. But in the homework or something, some people draw graph, for example, like
Professor, I have like a quick question. So
sure.
in the example you use the The project L minus S come out to be the IRR of the crossover of A68. So if is it make it different if we use S minus L?
That's a good question. Actually, same answer, right?
Okay.
But why I told you to do it L minus S, right? That is, if you do S minus L, then the project delta's net present value when WACC is 0 is negative. So your net present profile will be upward sloping rather than downward sloping like those. So it's not, doesn't look good, right? So it's like this. L and S, like let's say, okay. Then what? I told you that this crossover point is same as crossover point of delta project. So it has to be right below this crossover point, but in the exam or homework, some people draw like some people draw like, so it's like this and this. Then this one right below, this one is delta projects crossover point. So right below, but some people draw like just like this and this. And then what? Delta project has to be right below, but they just draw like this. Then what? That is not right below this. This is like this. That's wrong. Then you don't know what's going on with this delta project. The crossover point of x-axis should be right below this crossover point below L and S, right? Not only that, if you do S minus L, right? S minus L, then what? Then it's like this. Oops. It's like this. Like this, right? Then the crossover rate is the same, but you have to draw delta project like from bottom up like this, right? Then it doesn't look good, right? So everything is like downward sloping nicely, right? But delta project is totally just upward sloping and doesn't look good. That's why I want to check when WACC is 0, which one is higher? In this case, L is higher than S, right? So L minus S, then what? This one is positive, right? But so this is L minus S, right? But if you do a delta project, S minus L, then what? S minus L is negative, so you start from here and you crossover rate. So you doesn't look good, right? So that's why I suggest that when you draw your homework and in your homework, and of course, it's because of Zoom, it's hard to have this one in the exam, but in your homework, you have to make sure that you draw like L minus S, so it behave nicely. So that is how to draw net present value profile. Okay.
Hey, Professor, so are we gonna have to draw this and create the table in the exam?
Oh, let me see your face first. One more time.
Are we gonna have to draw this profile and then create the table in the exam, or no?
No, exam is hard to draw, so it's hard to be on the exam, right? That's what I'm saying. But homework, so homework, you have to show me this one, that this point should be right below this one, right below, right? Not like this, that this is wrong, right? They draw, but not be very careful, okay? This one should not be away from this one. That's wrong, right? That's wrong. Right below, right below. and downward sloping like this. That is how to draw net present value profile. And as you see, this net present value profile cross each other, but many times it could be like this, right? Like this. But in this case, why they cross each other? There are several reasons. So let's check. First, size or scale difference. Smaller project frees up funds at T equals 0 for investment, right? Smaller funds take less money, so more money is available for other projects, right? So the higher the opportunity cost, the more valuable these funds. So high R favors projects. By the way, Alex, do you have some raising your hand? Do you have some question about why do you have the palm on your screen? Yeah. Well, do you have a question or what? Why you have palm on your screen? Palm sign. What's going on?
I'm sorry, I don't know why that was on. My bad.
Okay, no problem. I thought you were just raising some issue. Okay. So like this. So smaller projects. So the higher the opportunity cost, the more valuable these funds. So high R favors small projects. Okay, because if discount rate is high, then what? Then money is more valuable, right? So R favors small projects. So then you have more money available for other projects. And also timing difference. Projects with faster payback provides more cash flow in early years for reinvestment, right? So if R is high, early cash flow is especially good. So that's why net present value S is greater than net present value L. That means what? If R is discount rate, definitely, right? And if discount rate is high, then what? Distant cash flows will be discounted heavily, even though that is distant distance cash flow is big, the present value may be small. Why? Because heavily discounted. But if R is low, the discounting is just light. So present value future value can be still high, right? Then what? Then big cash flow will be better. But if discount rate is high, then what? Then short-term cash flow is better, right? So it's like this. But everything actually depends on rate of return. So let me show you some example. Let's say project A, 300 investment, and 100, 200, and 300, let's say like this. And project B is bigger project, minus 600, 200, 400, 500, like this, right? Then if you calculate IRR, this is 36.19%. And this is 31.84%. So this is higher, more profitable than this one, but look at A prime and minus 600, 200, 400, 600, then you will have same IRR as A. So A and A prime are basically same profitability, except that A prime is twice as big as A, right? So as long as the return is the same, actually the size actually doesn't matter. So this one, size means it assumes that a bigger project is less profitable or lower IRR than smaller project, right? That's the assumption. But here, even is bigger than A prime is bigger than A, same IRR, then what? No crossover, the same thing. So let me show you what happens for net present value. Net present value of A net present value of A so net present value A when interest rate is 0, 300, 10, 182, 20, 96, 30, 32, 40, minus 17, like this. And B, 500, 288, 134, 18, minus 71. And project A prime, 600, 363, 192, 64, minus 34. So if you look at this one, A and A prime, the net present value of A and A prime is basically net present value of A prime is double of those ones. So A and A prime, the net present value profile will be kind of parallel, right? No crossover. But look at now A and B. This is what this means, right? Size difference. That is what. Big project, but lower return. But when discount rate is small, big cash flow dominates, right? 500, 300. Still at only 10%. Look at this, huge net present value over just A. And 20%, same thing, is what? 134 and 96. But look at this, at higher discount rate, 30%. Now, A is bigger than B. Same thing, is bigger than B. So that's what this means. That means the higher opportunity cost, that means higher discount rate, the more valuable these funds. So high R favors small project, but high return project, like this. So when it is high, NPV of A is greater than NPV of B. But even A prime is bigger than A, but as long as the profitability is the same, no crossover. Okay? It's more about the return. But for this one, for project LNS, right? it's a timing problem. L, big cash flow at the end, but S, big cash flow in the beginning. So if discount rate is small, and this has $10 more, like 10 plus 60 plus 80 is 150, 7 plus 50 plus 20 is 140. So $10 more, so more cash flow. So that's why, if there is no discount rate, 50. And with a very low discount rate, still NPV is bigger, right? So this one, project LNS, has some slight hint of some size and timing, right? So, that's why there is crossover, right? So left-hand side of crossover rate, L is better. Right-hand side of crossover rate, S is better. Yellow is higher than red, right? So normally net present value method and IRR methods normally gives same conclusion, right? Especially when they are independent, then normally, but not always, give the same conclusion. But if L and S are mutually exclusive, then what? Mutually exclusive, then you have to take only one, right? In that case, there is a ranking conflict. That is what? Between IRR and net present value. Why? Because, let me ask you, according to IRR, which project would you choose?
S.
S.
Check. No matter what, you have to choose S. So if your cost of capital is greater than 8.68%, then what? No conflict. You will choose S over L. But let's say if your cost of capital is, let's say, 7%, then what? Then what would you choose according to net present value rule? Like 7% here, then what? Then L is greater than, net present value of L is greater than net present value of S. So according to net present value rule, what would you choose?
Just choose L.
Check. L has higher NPV, right? If your cost of capital is 7%. Then what? Then there is a conflict. So using IRR rule, you always choose S no matter what. Using net present value rule, sometimes you choose L, sometimes you choose S, depends on your cost of capital, right? So there is a conflict. Which one do you think is better, net present value or IRR? Be bold, participation.
IRR.
Why?
Because it show like internal rate of return, like specifically, and then compared to the NPV, we just compare like if it's like greater than 0 is is bigger than the rate of return of the investor. So that's what my point. It just show that. It doesn't show like specific number.
That's a good point, but unfortunately, wrong answer. Wrong answer is better than no answer, right? Participation. The reason is this. There are many reasons. So that's actually a discussion point, right? Discussion point. First, reinvestment rate assumptions. That means, I told you that in finance, there is no free lunch. That is what. Like this one, reinvestment rate assumption is like this. No, like free lunch, that is what? Your interim cash flows like this 100. Then what? This one has to be reinvested. And this 200 also has to be reinvested. Same thing, this interim cash flow has to be reinvested. This one has to be reinvested. This one has to be reinvested. So those ones has to be reinvested, right? In finance, no free lunch. Then the question is, those interim cash flows will be reinvested at what rate? Okay, that is the key. So according to IRR, it says that you reinvest those interim cash flows at IRR. And according to net present value rule, you reinvest those interim cash flows at your cost of capital. Which one do you think is more reasonable? That is, NPV assumes that we invest at our opportunity cost of capital. IRR assumes that you invest at IRR. But the answer is here. Reinvest at opportunity cost is more realistic and more reasonable. So NPV method is best. So NPV should be used to choose between mutually exclusive projects. Then why reinvestment rate it should be R, or opportunity cost? To understand that one, you have to understand the nature of your finance. For example, like this is your company's vault. So all the money flowing, so like from project A, and dollar from project B, dollar from project C, and all sorts of dollars from different projects. Let me ask you, when you have all those money from all those projects in your vault or in your safe, can you distinguish which money is from which project, which money is from which project? What do you think?
No.
No.
Correct. It's like water, right? It's like water. So you when you have water from like California water is our water is from Northern California, or from Colorado, or believe it or not, from Arizona, right? Can you believe that? Arizona, you think is a barren area, but it's more water than California. Why? They have Grand Canyon. So once you have all the waters in your reservoir, you cannot distinguish which one is from which. Same, money is like water. When you have money from all the projects, now there is no distinction. So all the money has to be treated the same. Then what? The more reasonable assumption is that what? All the money will generate same expected return. And your expected return is actually, that is WACC. Why? WACC is your required return or expect return. Investors require, then what? You have to provide them WACC to get their money. So that is actually expected return. Expected return. Then what? Then it is really reasonable to expect return rather than IRR, because IRR, as you know, is specific to each project, right? Then how can you assume that all the cash flow in your vault is that project's return? It should be average return, right? So IRR rule is not reasonable because IRR rule assumes that the interim cash flows are reinvested at IRR. But as I said, IRR is different. Some projects IRR may be 10%. Some projects IRR can be 20%. Some very, very profitable IRR can be 30%. So then what? You cannot apply that huge 30% to all the cash flows. The reasonable assumption is that you have to reinvest all the cash flows according to your expected return. Okay, you are expected to get your expected return. So that's why reinvested opportunity cost R is more realistic. So net present value rule is the best. So, the IR rule has some critical flaw. That is what? All the cash flows will be reinvested at IRR. That's too much, right? Because after you do your project, those cash flows will go to what? Go to your vault, right? So that is more realistic. So you reinvest at your expected return, at your WACC. So that is more realistic. So net present value rule is better. Not only that, net present value rule is what? Shows you dollar amount. That is what? The manager's goal is what? Maximizing shareholder wealth, right? Or stock price, dollar amount. So think about this. If you have like project A and project B, it is 0, 1, 0, 1. You invest $1 and year one, $2. You invest $100 and year one, $112. Then what? Then this one is what? IRR is what? It's 100% IRR. This one is only 12% IRR. But net present value wise, it's just less than $1, right? So if you rely on IRR, it can be misleading. You just go for NPV. Let's say if you have like 10% like discount rate, then what? Then this one is what? 1 point something, only $0.9. But this one, that's not a good example. So 10%. That should be like 120. Let's change it. 120. Then this is only what? 20%, only 20%. Right? So you like 100% definitely, right? IRR. But dollar-wise, this is less than $1. 2 divided by 1, if your cost of capital is 10%, 2 divided by 1.1, minus 1 is just less than 1. But this one, 120 divided by 1.1 equals what? 1.0909 minus 100, and what? $9, huge profit. So, that's another problem. Focusing on IRR, it just high IRR doesn't mean it's high cash flow into your pocket, right? Not only that, this is a real problem. Normal versus non-normal cash flows. So normal cash flow project is that cost is negative cash flow, followed by a series of positive cash flows. One change of sign. So 0, 1, 2, 3, 4, 5. Then you have minus 10 invest. Then you have 2, 3, as 20, 30, 10, 20, 10, like this. Then what? Then sign, cash flow sign is negative, right? But all positive like this. Then only one sign change, right? Then that's normal. So, or this one is also normal, one sign change, 1, 2, 3, 4, 5. You may have to invest for 2 years, minus 10, minus 10. And then what? Then 30, 40, 50, 40, something like that. Then what? Negative, 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 negative to negative, positive, 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 positive. Then what? Then only one sign change. That's normal. But non-normal cash flow is 2 or more change of signs. That is what? You have a 0, 1, 2, 3, 4, 5. Then you have invest money, and then you get some $20. But you have to invest again. Let's say, then what? Then you have 30, 40, 50. Then what? Minus plus cash flow sign is minus, plus, plus, plus. Then how many sign changes?
Two.
2, are you sure?
No, 3.
3, check. Because from minus to plus, plus to minus, minus to plus, so 3 times, right? So in that case, then what? The IR method doesn't work. So most common thing is cost, the string of positive cash flows, then cost to close project. There is a, for example, nuclear power plant or stream mining. There is one. Nuclear power plant, you first you have to invest as a negative cash flow. Then what? You generate electricity and you generate income, positive cash flows. And then what? And then at the end of the project, you have to what? You have to just handle the nuclear waste. There is radioactive, very dangerous, these lots of cost to get rid of radioactive, materials, right? Or stream mining. Stream mining is that, the regular mining is what? You just make a hole or some cave, and you just get some gold or whatever, right? Stream mining is you just in fact strip meaning what? Cut all those hills land where you just get rid of all those things. Then what? You are just there is the hill is gone, something like that. Then you have to get it to a original state. Then what? That's definitely lots of money involved. Then what? At the end, you have to spend a lot of money. So those things are typical, common thing. But those things are also possible. Okay, you may, by doing your project, you may have to sometimes input more money. That's possible. So then what? That is a non-normal project. Then let's just examine which one is better, net present value or IRR, right? So if you choose between L and B, okay, L, so let's just calculate CF0, 100,000, negative. C1 is 120,000, enter. Go to IRR, compute, 20%. Then the A3333, enter. 100,000 negative. Enter IRR. Compute 20%. So project L and project B both have the same IRR. Same IRR. So are you indifferent? Again, as I said, wrong answer is better than no answer.
Yes.
Participation. Yes?
Yeah, because the
said-
cash flows.
So
That was me.
So why? Why?
Because the cash flows are different.
Cash flows are different. Cash flows are different, but you said, so you said yes, you are indifferent, right? Why you are indifferent?
Well, because I think going back to the slide, you get like a negative amount from the second project compared to the first one.
So the reason is not very clear. So you said you are indifferent, then you don't care which one, right? Why you don't care?
Oh, so no, you do care. My bad.
Oh, okay, you do care. So why?
Sorry, I thought so. Yeah, because again, like the cash flows are different. Like the amount you get a negative like return on the second project, I believe it was.
That's correct. Actually, both has the same IRR, right? Same IRR. But L is what? L is actually lending. Actually, L means lending. This is borrowing. The nature of cash flow is like this. Lending, you lend 100,000 and get, so this is actually into your pocket, right? But this is borrowing. You borrow money, it's positive, so that means you into your pocket first, you borrow money, and then later you have to pay 100,000. So this is actually more precisely minus 20%, right? You are paying 20%, right? So your return is negative 20%, not 20%. That's the problem of IRR. IRR just calculate the magnitude of the, like, what do you call, magnitude of the return, not sign of the return, right? Magnitude of the return. So 20% is just magnitude, not the sign. So lending, you invest, you get 20%, you get, so sign is positive. But borrowing is 20%, but actually it is, you are paying 20%, so that is negative. But, so that's the difference, another difference between IRR and return. Actually, so answer is no. Why? You are getting 20%, but borrowing, you are paying 20%, right? So the IRR may not be the right one. Just no higher number doesn't show that it's good, right? But because this one is actually minus 20%, because you are paying, right? But using NPV, pretty easy. NPV of L is 9,091. NPV of B is minus 7,000. Definitely this is not good, right? So if your cost of capital is 10%, project L gives more than you need, but project B, you are paying more than your cost of capital. So that's definitely bad. So that's it. Net present value is negative. So net present value shows you the clear sign. Okay, it's negative. So, you know, in that case, net present value rule is better. And then how about this one? This project cash flow, CF0 is one enter. C1 is 2, negative, enter. C2 is 1.5, enter, right? Hit IRR, compute. Error 7. That means what? The calculator got puzzled, right? They cannot calculate IRR. Look at this. This project, there is no IRR. No discount rate can make this project's net present value 0, right? No discount rate can make the net present value of this project 0. So there's no IRR. Then what? Then what? Then the managers just got puzzled, right? Actually, Tan's answer is really more consistent with general managers liking. That is, general managers like IRR rule. Why? Pretty simple, right? It's pretty simple. You know your company's cost of capital, and you know project's return. Then its project's return is greater than your cost of capital, take it. If it's less than your cost of capital, reject. Pretty simple, right? So they like, you know, IRR rule. But look at this one, no IRR, then how can you decide, right? Big problem, right? Then what? How about net present value rule? A net present value rule, using net present value, like go to NPV, I is 10, down arrow compute, 0.42 million. It's a good project, take it, right? But if you know only IR method, you cannot do it, no IRR, right? So in that case, definitely, net present value rule is better. How about this one? This one, cash flow, 800, negative, enter. C1, 5,000, enter. C2, 5,000, negative, enter. And go to IRR, compute, 25%. So do you want to take the project?
Looking at the cash flows, you wouldn't. Looking at the IRR, you would want to take it, but looking at the cash flows, you wouldn't.
So what's your decision?
Well, if you were just basing on the IRR, you would want to take it. If you were just basing on the IRR.
No, that's correct. According to IRR, you have to take it, right? But that's correct. But my next question is that actually correct? No. Why? According to IRR, you have to take it. But that's not a good decision, because this project has what? Multiple IRRs. It's not just one. Multiple IRRs. That's the problem. Then what? Look at this net present value. Net present value is huge negative. Reject the project. So according to IRR, you take it, but according to NPV, it's huge negative. As I said, the reason is the project has 2 IRRs like this. That is we call non-normal cash flows. So when this one is wrong, this one has to be here, 800, minus 800. When discount rate is 0, it should be minus 800. And then there is one IRR here, 25%. So this is definitely, this is net present value profile, right? Usually it's downward sloping, but this one go up and down. And there is another IRR that is what? 400%, 400%. So if your cost of capital is 10%, then what? This one is what? Minus 387, right? Huge money losing project. But if your cost of capital is, let's say, 100, then what? Huge positive NPV. So let's go back to here. That means this project, look at this project, 5,000 minus 5,000, but this is year 2. So if your cost of capital is high, then what? This present value of this will be small, right? But present value of this will be still high because it's just one period. This is 2 period discounting. So present value of 5,000 dominate these negatives and these negatives. So that present value is positive. But if cost of capital is low, like 10%, then what? Then present value of minus 5,000 is still big, and plus minus 800 will be greater than present value of 5,000, right? But if your cost of capital is too high, let's say more than 400%, then what? Then present value of 5,000 and present value of minus 5,000 are very small compared to this present value of 800. This is present value already, right? This negative 800 dominates. So, that present value will be negative. So it all depends on your cost of capital, right? So, simple net present value calculation will do it. Okay? Negative net present value, you reject the project. And besides, when you have, look at this, this one is what? 2 sign change, minus to plus, plus to minus, 2 sign change, then the maximum 2 IRRs. So famous how do you read this one? In English, it's Descartes' rule. But in French, it is something like that. Yeah. I study French, so like Paris, sous la pont de Paris, something like that. So he is a French philosopher, just mathematician, and scientist. He's kind of genius. He's a genius, and his rule is such that the maximum number of IRR is the number of sign changes. So it's like this. By the way, today's quiz will be 4:24. So 7 more minutes. So, not this one. Let me have just to make sure that I don't miss, because you may forget, I may forget. So that is like this: minus, plus, minus, plus, minus, plus, plus, minus, plus. Then how many sign changes?
Four.
Only 4?
5. 5.
Only 5?
7. Yep.
7. It's correct. 7. Minus to plus, plus to minus, minus to plus, plus to minus, minus to plus, plus minus, minus plus. Total 7 sign changes. Then it's like this. It's like 2, 3, 4, 5, 6, 7. Then what? This is what? When that present value profile crosses x-axis, that is IRR. 1, 2, 3, 4, 5, 6, 7, right? Then that's the maximum number, right? Maximum number, because it can be also like this. Then what? We have only one IRR, or there are possibly 7, but you have only one IRR, or you can have then what? Just tangent here, then what? 4 IRRs and so on. And this one, no IRR case, this one may be such that you have like, there are what, 3 sign change. So it's like, I don't know, like this, then what? No touching, right? No touching. 1, 2, 3, 4. This is 5, possible 5 sign changes, but no IRR, right? So that is, that is no IRR. And this one is what? This one, or not this one, no IRR. This one is sign change, plus to minus, minus to plus, right? So that could be like only possible 2. So either this or this, right? But doesn't touch x-axis, right? So no IRR, no IRR. So this can maximum 2, right? It can be like this, then what? There's 2, maximum 2, but in this case, it doesn't touch x-axis, so no IRR. So when sign change is more than 1, then you should know that IRR rule doesn't make sense, doesn't apply. So let's go back to here. So we have 2 sign changes, right? Minus to plus, minus plus, plus minus. So 1, 2 sign change, right? So we know that there are maximum 2, and one is 25% from calculator, but the other one is 400%, right? And you can actually calculate that one using just the definition of IRR. So IRR is what? Minus 800 plus 5,000 over 1 plus IRR minus 5,000 over 1 plus IRR squared equal what? Be bold. Hint.
25%.
Oh, no, here. Your answer is IRR, but finish this formula.
NPV.
What is here? Here means here. What is here?
0.
Check. 0. IRR definition. IRR is what makes net present value 0, right? So NPV, that is actually, this is NPV is correct. NPV is minus 800 plus whatever is 0 only when what? You have IRR here, IRR, right? So you can solve for IRR from here, right? So you can just multiply 1 plus IRR squared in either side. Oops. Time's up. So no more fun. So we'll have our quiz. Stop share. So today's